Welcome to the 5th grade. This is our last grade level that we're going to go through standards with in Math 277. In 278, we cover grades 6 through 8 standards, so we definitely get more intense. So we're going to do this week is operations in algebraic thinking along with number and operations in base 10. So here we have a few operations and algebraic thinking. So we're going to actually start doing quote-unquote algebra. Even though you've probably picked up that we've been doing it all along, we just haven't called it that. Grace says that 4 times 6 plus 2 is 26, but Lupita says that 4 times 6 plus 2 is 32. How do you think each student calculated the equation? So we have Grace and Lupita, the same equation, different solution. Looking at Grace, it appears that she multiplied 4 times 6 first, which is 24, and then added 2 to get 26. However, Lupita looks like she added 6 and 2 first, so 6 plus 2 is 8, and then multiplied that by 4 to get 32. We need the order of operations at this point. How do we know which one is correct? And we need to keep some consistency. So we need to do parentheses first, then exponents, which I know we haven't gotten to yet. We'll get to them in 278. And we need multiplication and division working left to right, and then addition and subtraction working left to right. So use the order of operation to determine who correctly simplified the expression from the previous slide. We need to do multiplication before addition. 4 times 6 is 24. Adding to 2 gives us 26. Homework. Oliver is making a snack mix to share with his friends, and he has $20 to spend on the ingredients. There are some guidelines. The mix must have at least 3 different ingredients. The mix must have at least 3 scoops of one ingredient, and the mix must equal $20 exactly. What are 4 different combinations of ingredients could Oliver use to make his snack mix? List the ingredients and provide a representation expression of the snack mix created and find the total cost of each combination. Scan and upload your combinations into the snack mix discussion board. Note that you do not have to reply to anybody on the discussion board, but it is interesting to see how others are thinking. Helen wants to make her own snack mix. Here are the items that she purchased. 1 scoop of chocolate chip costs $3. 2 scoops of dry banana chips cost $5 for each scoop. 1 scoop of peanuts for $3. 3 scoops of raisins cost $2 for each scoop. Write an expression to show the amount of money that Helen spent on her mix. If needed, draw a model to represent the snack mix. Pause the video and see if you can put together the correct expression. We should have 3 plus 2 times $5 for 2 scoops of dried bananas, plus $3 plus 3 times $2, so 3 scoops of $2 of raisins. It may be easiest to group them together so we can kind of see the 4 different pieces of the different pieces of the snack mix. So then we can multiply first. So 2 times $5 is $10, and 3 times $2 is $6. Adding them all up, her snack mix costs $23. An expression is like a recipe that lists mathematical calculations and has a specific order in which it must be evaluated. A specific value can be calculated by a variety of equivalent expressions that show the steps taken to evaluate them. Oliver has 4 pencils and 10 markers. Helen has 6 times as many as Oliver. How many does Helen have? Well, we know that Oliver has 4 pencils and 10 markers, so altogether he has 14 pieces. But Helen has 6 times as many as Oliver. So whatever Oliver has times 6. Well, 4 plus 10 is 14, and 6 times 14 is 84. So Helen has 84 pieces. Mr. Fun had 24 notebooks that he sorted into 8 equal groups. He then realized he needed to triple that amount for each group. How many total notebooks did each group need? We started with 24 and we divided it into 8 groups, but then he realized he needed to triple that amount. So we need to take whatever that result is by 3. And according to the order of operations, we work multiplication and division left to right. So 24 divided by 8 is 3, and 3 times 3 gives us 9. So each group had 9 notebooks. Evaluate 1/2 times 956 minus 22 times 41. Within parentheses, we need to do the multiplication first. So 22 times 41, envisioning that area model that we did in 4th grade, we would have 4 pieces since we have a double digit times a double digit. And the 4 different areas would be 20 times 40 plus 20 times 1 plus 40 times 2 plus 2 times 1. So altogether, we would have 902. Now we still need to work on things inside our parentheses. So we need to take 956 and subtract 902, giving us 54. Finally, we need half of 54, which is 27. An expression has a specific order in which it must be evaluated. The order of operations provides consistency when we evaluate expressions with more than one operation. We use grouping symbols to represent different mathematical situations. These sometimes change the value of the expressions and sometimes they do not. Is this equation true or false? 4 times 7 plus 8 is 60. This equation is false. Let's add parentheses to make it a true statement. Let's see what happens when I group our first two numbers together. 4 times 8 and then add 4 times 7 and then add 8. Well, 4 times 7 is 28, and when I add 8 to that, we get 36. That does not equal 60. So let's try grouping a different way. 4 times 7 plus 8. Well, when we're in parentheses, we have to do those first before multiplication. So 7 plus 8 is 15. When I multiply that by 4, we get 60. So we found the correct solution by adding in parentheses. Where can we add parentheses in the equation to make it true? Pause the video and see if you can't figure it out. Let's start grouping the first two together. 8 plus 26 is 34, multiplied by 6 minus 2 gives me 204 minus 2, which is 202. Nope, that doesn't work, so let's regroup a little bit differently. Let's group the 6 minus the 2 first, which would be 4. And then multiplication comes next, so 26 times 4 is 104. Adding 8 to that gives us 112, which is the solution that we needed. Below is a picture that represents 9 plus 2. So I have 9 light gray and 2 dark gray for a total of 11 altogether. Let's draw a picture that represents 4 times 9 plus 2. Well, if this is 1, we would need 4 rows of 9 plus 2 to get our correct solution. So then how many times bigger is the value of 4 times the quantity of 9 plus 2 rather than just 9 plus 2? Well, the value is 4 times as big because we can see that there were 4 equal rows above of 9 plus 2. Further, 9 plus 2 we know is 11, and 4 times 11 is 44, which is 4 times as many. Fill in the blanks given the following situation, given the following expression. 4 times the quantity 25 plus 16. Allie bought candy to hand out at the fall festival. Each bag had more pieces of hard candy. Each bag contained blank pieces of hard candy and blank pieces of chewy candy. She bought blank bags of candy. How many pieces of candy did she have? Well, looking at the objects inside the parentheses, those must be the types of candy I have. I have 25 and 16. We know that there are more pieces of hard candy than chewy candy. Therefore, the larger number of 25 must be the hard candy, and the smaller number of 16 must be the chewy candy. All in all, she bought 4 bags of candy. How many pieces did she have? Well, 25 plus 16 is 31. Multiply that by how many bags we have of 4, and that equals 124 pieces of candy. Homework. Choose one of the students' expressions below and write a real-world situation that could be represented by the expression. Then evaluate the expression. Scan and upload your work to the real-world discussion board. Respond to one of your classmates' posts. You will see the picture of the expressions located in the discussion board post itself. It was too big for the slide here. So view that, you'll see the 3 options that you have to choose from to create the real-world situation. Numbers and operations in base 10. We have 7 different standards that we have to cover. Which number has a smaller value of the digit 6? Prove your answer using a visual model. 5 and 36 hundredths or 7 and 6 tenths. Let's use base 10 models. A flat represents a whole piece, a long represents the tenths, and a unit represents hundredths. So if I have 5 and 36 hundredths and then 6, 7, and 6 tenths, 6 hundredths would be 6 little unit pieces, whereas 6 tenths would be 6 longs. I can visually see that the digit of 6 in 5.36 is the smaller value. Which number has the larger value of the digit 1? Prove your answer using a visual model. 1 and 2 tenths or 19 hundredths. I have the value of 1 in 1 and 2 tenths as a whole, which is just a box for short instead of putting all the little tiny squares. And 1 is in the value of the tenth spot, which would represent a single long or 10 little ones put together. I can see that a whole is much larger than a long. So the digit of 1 in 1 and 2 tenths has the larger value. When the place value extends to the thousands, the structure does not change. We can record a decimal number as the sum of the value of its digits. Write 0.342, so 342, in the expanded notation. This is said as 342 thousandths. Viewing this number in the place value chart, 3 is in the tenths location, 4 is in the hundredths, and 2 is in the thousandths. So 3 can be represented as 3 tenths plus 4 hundredths plus 2 thousandths. And if I were to add all of these fractions together, we will get 342 thousandths. We can extend this into the units by taking 3 copies of 1 tenth plus 4 copies of 1 100th plus 2 copies of 1 1,000th. We can also show the value of each digit within 342 thousandths using fractions that shows the powers of 10. So notice on the 100, it's the same as 10 times 10, and 1,000 is the same as 10 times 10 times 10.